Welcome to Pepperl+Fuchs Basic Training on Identification Systems. What is an identification system? An identification system is a product that can uniquely distinguish an item based on a mark, chip, or label. There are three basic types of identification systems offered at Pepperl+Fuchs. Barcode readers, you all know, simply read a one-dimensional or two-dimensional printed code. An RFID system is a non-contact system that has a read head with an antenna that reads a tag. Data is transmitted between the two using a specific frequency. Third type is also optical, but instead of reading barcodes, it reads codes in other forms. For example, it could read a series or holes drilled in a code plate for use in the high-temperature paint industry. The identification systems can be broken up into two categories: optical systems and RF systems. Optical systems use a camera, laser beam, or other type of imager to distinguish marks of a product. Because they are light-based, these systems require line of sight. They may not work very well in dusty and dirty environments because the optics could get blocked. Laser-based systems also have mechanical components that give it a limited life expectancy. RF systems have no optical components. They can hold up in the dirtiest of environments. Line of sight is not required, so it can read through dust, the human body, water, and so on. About the only thing it can't read is through metal. You can also write to RF transponders. Here's a quick look at a comparison between optical and RF systems. The one thing that stands out on the optical side as far as advantages is the integration effort. Optical systems have been used for years. Barcodes can be incorporated into scan sheets and routing documents with little effort and no additional cost. Barcode data is typically coded in ASCII, and once scanned by the barcode reader, appears on the screen as you type it. Many, if not all, barcode readers are interchangeable. What RF systems lose in integration effort, they make up for in every other category. You can write data to tags, updating them on the fly. Line of sight isn't required because the RF system need not see the target. Also, unlike laser barcode systems that use a rotating motor, no moving components are required. This is a classic RFID application, and probably one of the first ones ever to use a Pepperl+Fuchs system. Machining centers need to verify that the correct tool is in the fixture before the machining operation starts. If the wrong tool is in place, it could cause hundreds of thousands of dollars of damage. In this picture, the green chip is mounted in the side of the tool holder, and the read head verifies the correctness of the tool before work starts. RFID is common in material handling. The tag is mounted to a tote or pallet that carries the parts being modified or worked on. The work is performed at each station. Pass-fail information can be written back to the tag, making all historical manufacturing data ready for the next station. At the end of the process, a good part can immediately be passed and sold to a consumer, and bad parts can be routed to an offline rework station for repair. Later on, after repairs are complete, the parts can be sold and no bad products ever get to the consumer. In process applications, hoses from a manifold frequently get connected together or get connected to a tanker truck. Before the valves are open and a liquid product gets routed through the pipes, the RFID tags are read and connections are verified. A wrong hose connection can cause the wrong mix of products. All of that product could possibly end up in a landfill. Before RFID, everything was inspected by eye and double-checked by a second person. Even this was not enough to prevent mistakes. RFID used in machine access is relatively new. The idea is to prevent anyone from entering the machine without the proper credentials. This might be an important process, and only a specific supervisor has the authority to perform it. These RFID systems go directly into PLCs and are located on industrial equipment, so standard commercial RFID door access systems are not appropriate. This also allows you to track the workers who use a specific machine, allowing for complete accountability for a job. This is just a small selection of applications. For the last 2 years, we have come out with a monthly letter showing real-world applications. You can use these to approach customers, and it may give you some ideas on new ways your customer can use RFID. Go to sensing.net/applications for all the application write-ups. Pepperl+Fuchs RFID systems are available in 4 main frequencies. These systems will be abbreviated low frequency, high frequency, ultra high frequency, and microwave respectively. In general, the lower the frequency, the less range you will get. The low and high frequency RFID systems are categorized into short range category. Maximum range is typically 6 inches or less. The ultra high frequency and microwave frequencies will be our long range systems. Read range will be up to 6 meters. The low frequency system was our first system. The lower the frequency, the more penetrating power the system will have, and it will be better around metal intensive environments. The high frequency system is also good around metal, but typically specially tuned tags or large spacers are used. The higher frequency system is an open system with many more chip manufacturers, resulting in higher capacity tags. The higher frequency system also results in cheaper tags, faster speeds, and a shorter interference range. All systems have a read head and tag. The tag may also be known as transponders, and the read head could also be known as an antenna. Low and high frequency systems are not interchangeable. A low frequency read head must be used with a low frequency tag, and a high frequency read head must be used with a high frequency tag. Check the model numbers to make sure the system components are compatible. The nomenclature is simple. All high-frequency systems start out IQ. For example, a read head is an IQ H1-FP-V1, and a tag may be IQ C21-30P. All low-frequency systems start out IP. For example, a read head is an IPH-FP-V1, and a tag is IPC03-50P. Within the short-range RFID systems, the high-frequency system is special. Neither low-frequency or high-frequency systems are proprietary, but the ISO 15693 standard that high-frequency systems adhere to make it widely adapted. There are a very large number of chip suppliers that provide products to companies like Pepperl+Fuchs. We then embed this chip and antenna coil into an industrial housing. We can read tags made by our competitors, and they can read our tags. There is no longer a worry that we will discontinue something that you can't get anywhere else. RFID systems are now worry-free, and your investment is safe. When mounting our read heads in or on a metal surface, take note as to how far the plastic tip must be away from metal. The L2 Rhino-style housing must hang over the metal surface by 50 millimeters. The tips of the cylindrical read head must be completely exposed or flush with a certain amount of metal material removed. When mounting according to this table, you are guaranteed more than 75% of the maximum document's read range. If 2 read heads will be running at the same time and you want no multiplexing either by the user or the controller, then you must separate the 2 heads by the multiplex off specification. In this example, 2 high-frequency heads would be separated by 80 millimeters minimum. If 2 read heads will not run at the same time, or will be multiplexed automatically by the user or a controller, then you must separate the 2 heads by the multiplex off distance at a minimum. Even though the head is not running, the resonance circuitry of the read head will still interfere with one another. For some perspective, the same size, low-frequency head requires 180 millimeters of separation minimum. Let's talk about the read range a little bit. The range is specific to certain tag read head combinations. On each tag datasheet, you will see a curve that shows where the tag can be read when the tag is parallel to the read head. All the read heads will be on one curve. Depending upon the tag design and the testing done, there may be curves for mounting on non-metal surfaces. We call this in-air mounting. There could also be curves for on metal with spacer, or for flush mounting in metal. High-frequency tags can be read and written at the same range, but the low-frequency systems have a shorter write range than read range. For low-frequency read-write tags, there will be 2 curves for each, one for reading and one for writing. This is an example of all the measured read range curves for the IPC03-50P tag with the 18mm, 30mm, flat pack, System P head, Rhino read head, and F15 large read head. You can see the largest read range for this tag is for the largest read head, IPH F15-V1 at 110 millimeters. If you want to achieve the most range possible, bigger is better. Generating the graphs takes a lot of time, so not all tags, especially non-standard ones, have read range graphs. The maximum ranges have been successfully tested, however. If you look the part up on our website and check under Documents, you can download this file. It is called the Manual Read-Write Ranges RFID. This is a table from the Read-Write Range document. In this circled example, the tag can be read from 0 up to 16 millimeters for reading and 0 up to 12 millimeters for writing. Many times, a read head is triggered to read a tag as it is stopped over the read head. This read field curve, as listed on the datasheet, guarantees that 99.9% of all tag and read head combinations can be read under that curve. It is suggested that you mount the tag from 30% up to 80% of the maximum range from the reader. Any closer and you risk mechanical damage if the tag hits the head. Any farther and the mechanical tolerances could take the tag outside the read zone. If the read head is running a continuous read command and the tag will be flying by the read head, you need to be a bit more particular about this mounting. To maximize the read speed, the tag needs to be in the field for as long as possible. This means the fattest part of the graph. We suggest mounting it at 50% of the maximum read range. You want to make sure the tag isn't any closer than where the read field starts to get narrow at the bottom, and it must be well above the side lobe. Don't make it any farther than where the read field starts coming to a point at the top. When the read field curves talk about read range in air, they really are referring to the mounting of tag on any non-metallic surface. Remember that line of sight is not required, so you can mount the tag on plastic, wood, or rubber, and then put some other non-metallic material between the tag and the read head, and the range will not be affected. Here are all the tags that can be mounted in air. They are typically thin discs with or without a hole in the middle. There is a wide selection from as small as 10 millimeter diameter up to credit card style. Don't mount them on metal without a spacer. Certain tags can be mounted flush in metal. Never recess the tag or the range may be severely reduced. Typically, aluminum has little worse read range than steel, but check the datasheets to see if there are different read field curves. These special tags are thick and have ferrite cores. This ferrite material allows the read head to read the tag properly even when flush mounted in metal. Embeddable tags come as small as 8 millimeters or as large as 30 millimeters. The 39 millimeter tag actually has a 30 millimeter threaded body with a cap that lays on the surface of the metal. When gluing tags into place, use a soft epoxy to account for expansion and contraction of the different materials due to temperature. You also see here a picture of a tool that can be used to insert or remove the 16 millimeter or 30 millimeter tags. It fits in the holes located on either side of the front of the tag. Often, but not always, metal mount tags are thicker than normal tags. They have the spacer built into the housing. Use the correct screw when mounting any tag, especially if it is a high temperature tag. If the tag is too tight, the housing could expand and crack under the pressure. The metal mount tags range in design from the conveyor mount rectangular style to thick cylindrical versions. There is also a special high-frequency metal stick tag that has an adhesive back. These tags should only be adhered to a smooth, clean surface. Once attached, they won't come off without damage to the tag. You can also take a standard thin tag and mount it on metal using a spacer. There may be a read field curve on the datasheet with the range with 10 millimeter spacer. Also in the read range manual, there is a table for this specific case. Any tag that uses a spacer over 30 millimeters will get little or no read range reduction. Check out the different accessories available. We offer 7 millimeter spacers, 30 millimeter thick spacers, and mounting blocks for 16 millimeter tags. We have a wide selection of read heads available for low and high frequency. The basic differences are the size and shape of the antenna inside. The bigger the head, the more range you will get. The 30GM105 read head at the bottom right-hand corner is a special housing, ATEX approved for hazardous locations. You should also use hazardous location tags with it. Otherwise, just pick the read head that physically fits best in your application and that gives you the range that you need. To recap, when matching up a tag and read head, make sure the sizes are reasonable. For example, you may not want a large flat pack read head matched up to a 10mm diameter tag. Check out all of our available read head options at www.sensing.net/readers. Once you have your read head and tag housing styles picked out, there is another consideration. How much memory do you need? We offer tags with a memory capacity of up to 2,000 bytes of RAM. In general, more memory costs more money. Also, we have assigned a specific model number prefix for each RFID chip type. So for example, if you look at tags of type IQC24, you know that all those tags will have 992 bytes of data, EEPROM memory, and an 8-bit fixed code. The tags have different memory types. The ROM data on a tag is a lasered code that can never be changed and is never lost due to age. The read-write portion of data is stored in EEPROM or FRAM. EEPROM will have limited write capability of 100,000 times. The data retention of the data even after 100,000 is still 10 years. FRAM, on the other hand, is practically unlimited. The write limit is at least 10 billion. If you are going to be writing to the tag hundreds of times a day, then think about using the FRAM tag. If you want a read-only tag, you don't have to focus just on the IPC02 low-frequency read-only tags. All tags have ROM data on them. As long as you stay within a specific model number like IPC03, all tag numbers will be unique. We call these unique read-only codes that were lasered at the factory fixed codes. Our available tag options are ever increasing. We put an easy-to-use model number selector guide on the website at www.sensing.net/tags. If you are specifying a new system, you should lead with a high-frequency system. It is a higher performance system that will give you more safety margin and faster cycle times. It adheres to ISO 15693, which makes it an open system. This drives the selection of tag options up and the tag cost down. Also, the mutual interference is lower, so this means you can get the heads closer together if the application demands it, without any performance loss. Low-frequency systems are not going away, and we have some very nice standalone systems that may be right for your application as well. We have two long-range frequencies in microwave and UHF. Microwave definitely makes out in the read range category. The battery-backed tag allows these systems to get read ranges out to 6 meters. Microwave also has fewer multi-path read issues as compared to UHF, and you get better read range control as a result. UHF wins in most other categories. There is no battery, which drives the cost down to as low as 10 cents per tag. Write range is a lot longer than microwave, but I think most people use both microwave and UH systems as read-only systems. The unique identifier on the tag is used to distinguish one tag from another. Because UHF tags have no battery, many long-range logistics applications open up. You can track pallets in and out of a facility, and you can track trucks through a gate access system. Well-controlled UHF systems will also be used on the factory floor to track cars and other large objects. The UHF frequency spectrum is controlled by the specific telecommunications agencies from within that country. You cannot buy one reader and expect to use it in the USA and Germany at the same time. There will be at least 3 specific models for various areas around the world. The USA version will work with most parts of North and Central America. Other readers will be for Europe and China. Other countries around the world may also fall into one of these frequency bands. In addition to frequency bands, every country has certain UHF frequency access and power requirements. Tag mounting in UHF is not simple anymore. You have to be aware of the material that is between the tag and reader, as well as the material the tag is mounted on. Typically, you buy a tag for mounting directly on metal or one for mounting on non-metallic surfaces. When setting up a UHF system to maximize range, the tag should be parallel to the reader. Also, obstructions around the reader and tag must be taken into consideration. It isn't just the object directly between the tag and reader that has an effect, but also the devices next to them that will have an impact. Most UHF tags are polarized. You can use a linear, polarized antenna and align the tag and reader either vertically or horizontally, or you can configure the reader as a circular polarized antenna. A circular polarized antenna can read a tag in any orientation as long as it is facing the reader. UHF systems can be susceptible to interference. The interference is caused by the field generated by the reader bouncing off objects in the vicinity of the tag and reader. You can get two different effects. Signals can combine in a degrading effect, causing a hole in the read field. If you put a tag in this hole, it would not be readable. The second effect is an additive effect where an excessive read range can be achieved. This can lead to unforeseen consequences of reading a tag in another work zone or another production line. To minimize multipath propagation problems, try to keep the read power as low as possible. Keep as many obstructions out of the way as possible. In your design, allow for adjustments. Use accessories that allow you to move the reader into different positions and make new trials. In the end, you're going to have to test your system to make sure it performs the way you want it to. There is a huge market of UHF tags. You can find tags that range from 10-cent sticky tags to $30 high-temperature tags. All tags have a unique identifier as well as a user-definable EPC code. In addition, there may be a certain amount of read-write data available for use. We say microwave when talking about a frequency of 2.45 gigahertz. It is true that it is the same frequency that is in your microwave oven, but at far less power. It is the same safe frequency that is used with a Bluetooth wireless headset, keyboard, or in your car. Also, it is the same as Wi-Fi that you use at home, 802.11b or G. Microwave applications are long range. Because the maximum range is 6 meters, it is perfect for final assembly for an automotive manufacturer. It is also used for mobile transport tracking of trucks, buses, or trains. It is also used in other factory automation jobs where long read range is a must. The two main things that will affect the range are water and metal. They will obstruct the view of the tag to the reader. The mount of the tag on a metal or non-metal surface is not a concern. Either are okay. For maximum range, the tag should be orientated parallel to the reader, and the long dimensions of the reader and tag should be lined up. We have both commercial grade tags and industrial tags. These tags need to have a battery that is sealed. These are long life batteries that will last a minimum of 6 years. When batteries get weak, a low battery indicator is continuously sent by the tag so it can be replaced. Data is protected and guaranteed correct by CRC error checking algorithms. The tag data is sent at regular intervals and is not dependent on whether or not it is being read. The microwave tags send an ID frame to the reader that contains the read-only data, user-definable tags, the CRC, and the status. You can also configure the frequency at which this data is sent. The quiet time, also called the tag interval, is a multiple of the ID frame. The quiet time is either 0, 4 times the ID frame, 8 times the ID frame, or 16 times the ID frame. The longer the quiet time, the longer the battery will last. During this quiet time, other tags will have a chance to talk. So in general, the longer the quiet time, the more tags can be read at the same time. To reduce the risk of two tags sending their data at exactly the same time, a random interval should be used when multiple tags are in the field. The read-only MTO tags will always send data at an R8 random interval. There are 4 different RFID systems provided by Pepperl+Fuchs. They are Ident Control, Ident I System P, Standalone Systems, and Ident M System T. I'm going to talk about each one of them next. Ident Control is a very powerful system consisting of a read head and a controller. You pick the read head with the right frequency, size, and read range, and then pick a controller that will connect to the upper level bus that you need. The controller concept allows us to make one network controller and then have it immediately available for all low frequency, high frequency, and ultra high frequency ident control compatible read heads. Read heads can be as small as 18 millimeters in diameter or as large as we want. Using a controller allows for the integration of a wide selection of connector options and multiplexing. Cost is reduced because only one network is needed for up to 4 read heads. Also, the bandwidth is reduced because one TCP IP message is sent per controller rather than per read head. Easy configuration is now possible. A graphical display and keypad or rotary switches can be used to configure the network. 2 controller options are available. A 4-channel version has a larger housing that is capable of supporting push-pull connectors, a graphical display and keypad, and up to 4 read heads. The ident control compact supports 1 or 2 channels and is limited to configurations using rotary switches. All network interfaces and power connections are using standard M12 connectors. We have industrial controllers made for DeviceNet, Profibus, Ethernet, Serial, CC-Link, and EtherCAT. Not every network is available for both the standard or ident control compact version. Pick the controller and network interface that best fits your needs. Our Ethernet controllers support all Ethernet protocols at the same time. If you communicate to these controllers with Profinet and then decide to change your PLC platform, you can quickly and easily switch over to Ethernet IP or another protocol. In addition to the industrial protocols, SMTP email protocol is also supported. If a status message is generated because no tag is present or a read head is damaged, an email can be sent to a maintenance crew to go and fix the problem. The web interface allows you to quickly look at the configuration of the unit, and all recently sent commands and responses are logged. This log can be analyzed as an advanced troubleshooting tool. People sometimes ask what network protocol to choose. The customers know, just ask them. Based on the PLC you are using, the network choices are typically obvious. For example, on Allen Bradley PLCs, Ethernet IP is the network of choice, but Siemens will use Profinet. Mitsubishi will use CC-Link, and Schneider will typically use Modbus TCP protocol. Go to www.sensing.net/controllers for all ident control model number options available. All controllers are made from thick cast metal housings. We apply the Faraday cage principle here. All devices that are shielded properly can't cause interference and can't be interfered with. The metal read head and controller housings are grounded at multiple points to allow the closest path to ground for all noise sources. Often people ask how far they can run the read head to the controller. The limit is 100 meters. You could even go further if you increase the gauge of the cable. The cables are just standard shielded cables. The shields of these cables are connected to the coupling nuts on both ends. There are multiple through-hole mounting points on both the 4-channel controllers as well as the compact versions. The 4-channel controllers have a built-in DIN rail clips. The compact controllers can be connected to the DIN rail if you use a DIN rail mounting accessory. If your compact controller has rotary switches for configuration, just make sure that you configure the controllers before you mount the DIN rail base on the back. This DIN rail adapter will cover almost the entire back of the unit. As stated before, the 2 configuration options are the graphical display and keypad or the rotary switches. Pick the controller that best works for you. The graphical display is unique because a lot of configuration options are possible using it, including inputting IP address, subnet mask, and gateway information for the Ethernet controllers. Read heads can be activated for troubleshooting purposes. Read heads can be configured with the correct tag type settings. Use only heads designed for ident control. These heads all have an H in the model number, like IPH, IQH, or IUH. These heads must be connected to a controller and do not work standalone. Our ident-I System P system is a low-frequency system that is also very popular. It is especially useful for small installations requiring one read-write head connected back to a PC or PLC using RS-232. All connections are made directly in the base of the read head itself. There is a single read head model, IPT1-FP. It is a larger flat pack read head. Because of the size, typically only larger tags, not embedded in metal, are used. There are a number of base options. The short, compact base options are for RS-232 or RS-485 serial communication. Even stainless steel bases are available for food and beverage applications. Multi-drop bases allow all heads to be daisy-chained together and then connected back to a single PC. Each head can then be pulled one after another by an upper-level control system. We have a base that's a bit larger for use with our other industrial buses, Profibus and Interbus. These bases have cord grips or quick disconnects. All dip switch settings are located under the mounting cover for easy access. The bases are all solid machined aluminum for superior noise immunity. For all System P read head and base options, go to our www.sensing.net/readers webpage. Along with ident-I System P, these are some of other standalone options. All of these heads are being used primarily by OEMs. The main reason is they have the time and know-how to integrate these RS-485 read heads into their control system. The sizes are as small as 18 millimeters or as large as flat pack read heads. The system requirements are important. Make sure to use shielded cables when connecting these heads and ground the shield properly on both sides. The 24-volt DC power must be fused to prevent a surge from damaging the unit. Also, for the highest noise immunity and CE approval, you should keep the read head cables 3 meters or shorter. The most popular way to use this head is a simplex configuration. The read head powers up and starts reading automatically. When a tag arrives, the data is automatically sent to the PC. When the tag leaves, an additional status message is sent to the user with updated information that the read head has left the read zone. Some high-usage customers have us do the pre-programming. Other customers will just do the reconfiguration themselves before installing them on the machine. All standalone read heads have a T in the model number, IQT, IQT1, and so on. The IQT and IQT1 read heads differ in the ability to read the IQC33 type FRAM tag. The IQT1 read heads are also much faster. There are 2 protocol options. The R4 option is a simple point-to-point protocol option with a built-in RS-485 termination resistor. The R4M is a simple multi-drop protocol where up to 30 read heads can be bussed together. The heads are just pulled one at a time to retrieve the tag information. A model number selection guide can be found at www.sensing.net/readers. For high-volume OEM special opportunities, please contact the product managers at Pepperl+Fuchs. The ident-M System T is our long-range microwave system. This system is also standalone. You pop the cover off and you get connection to Ethernet ports, 2 serial ports, digital inputs, and 3 outputs. We have 2 different models of read heads available. The first is a 3-meter read-only unit. It can read read-only and read-write data, but it can't write any data to tags. The 6-meter unit has double the read range. The write range is short. The maximum write range is 0.25 meters. Because of the short write range, this system is typically used as a read-only system. A tag is written once, let's say on the beginning of the assembly line, and from then on it is read-only. The free software can be used to configure this unit serially or over Ethernet. This software allows you to configure the mode of operation as well as the prefix, suffix, and length of the barcode data. I say barcode because this unit was originally designed as a sort of barcode emulation unit. It does everything a normal barcode reader would do, including responding to normal barcode reader commands like laser on and laser off commands. This reader has a standard Ethernet port that can communicate using a standard TCP/IP socket connection. If you need to communicate using an industrial protocol like Ethernet IP, Profinet, or Modbus TCP, then use a converter. These converters will actually convert Ethernet to industrial Ethernet and serial to industrial Ethernet at the same time. There are 1 and 4 channel versions available. 4 different tags are available for various applications. There are 2 housing styles, light duty and industrial. Also, you can get a read-only or read-write version. All tags include an 8-byte mark. This is the read-only code, sometimes called the fix code. It is guaranteed unique. Up to 71 bytes of data can be written to the read-write tags. We're often asked, what system do we choose? For short-range systems, start with ident control and our high-frequency heads. They will give you almost any industrial bus connection, high-performance read heads, and low-cost tags. Use our ident-I System P solution when only a standalone RS-232 is required. Use the ident-M System T reader for long-range applications. Use our standalone RS-45 read heads for high-volume OEM accounts.